You all settled down? Ready to learn some new stuff and old stuff? I first wrote to Dr. Brown some months ago and I said, actually, I don't know if you wrote first or I wrote first. We wrote first. You didn't write first? Okay. So I said, what, tell me things so that I can give a more interesting introduction, a bigger introduction than just what you're going to already have read. And he wrote back and said, the first rule of speaking is to know your audience. And I don't know this audience. So we corresponded some back and forth about this audience. But as you might imagine, trying to describe what your interests are all in one compact sentence didn't work very well. And I just kept telling him, don't worry, they're going to be interested in what you have to say. I'm interested in what he has to say. I love to know everything about a fiber from while it's still in the ground until it's in my hands. And that's what he's going to tell us today. So, Dr. Steve Brown, thank you for coming.
Yeah, I didn't know exactly how I got this invitation, but I've been working and thinking about this for a year or so. And my wife did leave. My wife, Lisa, stand up, please. She's been a long supporter of my 47-year or 8-year career. And she leaned over a while ago and said, I think you're in the wrong place. I'm an agricultural scientist, so anyway, so I'm speaking to you from that regard. And if you have questions, don't hesitate to ask. I'm also used to engaging the audience, so I may ask you some questions and we can take it from there. If I can advance the slide, let's see. Okay, this is kind of an outline of what I'm going to say. I'm going to kind of tell you about my roots. Unintended, I guess. I'm going to talk about cotton from a biological, botanical standpoint and some of its history. Talk about one of the huge challenges of cotton. Somebody brought it up to me early this morning. Oops. The boll weevil and some of the other challenges that have occurred, and then some of the technology advancements that have brought cotton or sustained cotton as a modern crop. When we talk about Cotton Incorporated, I hope some of you are familiar with Cotton Incorporated. They are a grower-initiated, grower-funded organization that whose sole objective is to advance cotton in every aspect, particularly from the textile manufacturing standpoint. They also do support agricultural research. And then I'll finish up if I have time talking about fiber quality. Okay, this is not my dad. But that is him on the right. But my dad grew up in Hurtsboro, Alabama, which is about 3 hours south of, maybe about 3.5 hours southeast of here, about 30 miles south of where I live in Auburn, Alabama. Not known for rich agricultural land, but he grew up there. And so I think shortly after high school, he grew 6 acres of cotton. And it's a little fuzzy in my mind, but it was either behind a steer or an ox, which is not the standard animal power. He made a pretty good crop, a bale per acre, which was really good in those days. But it taught him, he said, I think I'm going to college and get another degree and learn something. He actually, and all my family came to this institution, the University of Alabama, and I went to Auburn University. But he came here after a stint in the Air Force during World War II and met my mother here. So he learned about cotton firsthand and said, I'm moving on. And this is not my mother either. But my mother, Nell Brown, Emma Nell Hudnall Brown, her daddy was Joel Henry Hudnall. And she grew up in Monroe County, Mississippi, about probably 50 miles from here, west, maybe northwest, a little bit in the poor part of Mississippi, near Aberdeen, but her little community, her crossroad was called Lackey. And Joel Henry Hudson, not Hudson, but Hudnall, her daddy was a cotton farmer and a cotton ginner. And this is a modern gin saw, but it makes the point, if you touch it, it's unforgiving. And my grandfather had one arm because he lost an arm in the cotton gin. But my grandfather, Joel Henry Hudnall, he married and had 6 or 7 children. His first wife passed away. He married again and had either 6 or 7 more. And my mother was the last of the last. And my mother had an aunt named, who spent her adult life in Covington, Louisiana. But she is quoted as saying, and this is cottonseed, but she is quoted as saying, having witnessed firsthand a lot of the challenges of cotton, she said, I wish I had the last cottonseed in the world. I'd put it in my mouth and I'd swallow it. And thankfully she did not. So anyway, so my mother's background was, again, raised in cotton in Northeast Mississippi. She came to the University of Alabama and met my dad here, and here we are. So I come from those sorts of roots, but I didn't grow up on a farm. I grew up for the most part in Dothan, Alabama. Anybody ever heard of the James Herriot books? Yes. Well, I had an aunt that lived in poor rural Mississippi, Scuba, Mississippi, East Mississippi, on a poor farm. And when I was in the probably junior or senior in high school and thinking, where am I going to go to college? She sent those books to me. And I thought, oh, I would love to work with my mind and with my hands and work outdoors. So I thought it was great. So I said, I'll go to Auburn. The rest of my family came to this institution. But after a while at Auburn, I realized, wow, really hard to get in vet school. And I don't want to go to school all my life. So anyway, here I am. But I did complete I also had I started in the pre-vet curriculum, but that I thought, that's not for me. Organic chemistry wasn't for me. But one of my high school classmates was in agronomy and soils. Agronomy is really, if you might say it, simplified, say it, crop science. And the idea of producing things, being involved in making and growing and producing things, that really appealed to me. So I moved my major, or however you say that, to the agronomy and soils. And, in some sense, the rest is history. I graduated. I got a degree, I got my degree and then started as a county extension agent in North Alabama in one of the major cotton counties. And my sole job was to work on cotton. I also worked with scientists nearby who, particularly a weed scientist, and he worked on cotton and other crops, and I became his research guy. And so I completed a master's degree with him, and I was single at the time and not in debt. So I said, well, I'll go on for a Ph.D. And I went to Texas A&M, and my focal crop there was cotton. And then because I graduated from there, my wife and I got married on July 4th of 1986. And so we hope to make 39 years in a few weeks. But anyway, so I started University of Georgia, and my assignment was cotton and peanut weed control. And then after a while, when somebody else retired, I moved into the extension agronomist role for cotton and really led a team of folks on cotton. So again, my focus on cotton, that was it. So I worked for University of Georgia for 21 years and understood that culture. And I'm going to talk about the land grant mission in just a minute. It's kind of I'll take a detour. And then after 21 years, I thought I was born to do this, but the more you can do, the more you get to do in the university system. And I said, well, I'll consider other opportunities. And there was a company that I thought, hey, I believe they can compete with Monsanto. And so then I went to work as a cotton development specialist with Dow AgroSciences, a company that's currently, actually the day after I retired from them, they officially became Corteva. And then the next day after I retired from Corteva or Dow AgroSciences, I became an assistant professor at Auburn University, back where I started, began working on cotton. And I retired last July, but I'm continuing to teach crops-related courses once a semester. So that's a little bit of who I am. But I want to take a sidebar here. Land grant institutions in Alabama, it's Auburn University, historically black colleges, Tuskegee and Alabama A&M. And in other states, you have the same. But in other states, land-grant institutions would be Mississippi State, University of Tennessee, University of Florida, University of Georgia, Clemson, Ohio State, Texas A&M,
Michigan State.
okay. Okay, all right, we'll stop. In 1862, the U.S. Congress passed the Morrill Act, not moral as in immoral or moral, but moral for Justin Morrill. And it was the Land Grant Act, and it commissioned states by giving them a certain amount of land for each representative to fund, and I believe the number was 30,000 acres per representative, to fund the establishment of institutions that would teach agriculture and mechanical arts. Now, in that realm of mechanical arts, obviously they meant engineering and sometimes some military type stuff. So that was instituted in 1862. Of course, we were at the Civil War at the time. After the war concluded, the southern states were, I don't know what you call it, grandfathered in. And also in 1890, the historical black colleges in some of the states were also awarded that land grant status. But after a few years, or after a number of years, in 1887, okay, we're teaching agriculture and mechanical arts. It was realized, hey, we need to expand the body of knowledge in those areas, particularly in terms of agriculture. And so they passed the Hatch Act, and there have been numerous Hatch Acts that have been passed through Congress since then. But in 1887, they passed the Hatch Act to establish agricultural experiment stations in each of the same states, usually associated with those who received the grants for instruction. And then in 1914, they say, we're generating all this information in the ivory tower, if you've ever heard of the ivory tower. But hey, we need to extend that information to the users, to the farmers, to the homemakers that are out in the state. And so the Smith-Lever Act was passed in 1914. And thus you have the three-legged stool of the land-grant institutions. And in my estimation, it's really science for the people. Now today, I pause to say that the greatest emphasis is on what branch of these three-legged stools, what's really the greatest interest of today? Research, why? It's money. But anyway, it's still science for the people. So that was just a sidebar I wanted to pass along. So let's talk biologically about cotton. It is a unique plant. Most of the crops we grow, the row crops we grow, they're annuals. In other words, they grow from seed, they complete their cycle in 1 year or one season, maybe 6 months or so. Well, cotton is actually a perennial species that's more shrub-like, and it can become woody. And if we stayed in a warm culture, a warm climate, I should say, it would keep on going and keep on growing. But now we've modified it over maybe 400 years or so. In fact, I'll say my brother-in-law was in the military in the Middle East and sent us a picture of his house. And right there alongside his road, or right by his driveway, was a cotton plant, but it must have been about as tall as the ceiling. So cotton, again, is a perennial, but we've modified it and bred it to produce seed and fiber. And again, that's really what we're trying to do here, not grow plant, but grow something that's going to produce seed and fiber. So the cotton is in the oops, you can't see this. Let's see if I can. The Malvaceae family. Anybody ever heard of that? Or mallow family. Anybody know some other plants in that family? Willow's mallow. What else? Okra. That was the one I was looking for. Okra. There was another one I was looking for. Hibiscus. That's the one I was looking for. So that's the family, and the way you classify plants is really by reproductive structure. And so again, all those have some similarities in terms of reproductive features. So the genus is Gossypium. Now I'll see if I can advance here. So again, I've already said that it's a subtropical, and by subtropical, it's the Central America region and band across the globe. That's really where it originated from. And there are actually multiple species that are grown commercially as cotton. Really, the top two are the only ones that matter. So we have Gossypium hirsutum, which is upland cotton. You can see where it originated from. And then we have Gossypium barbadense. That's Pima cotton. Some people, it would also be labeled as Egyptian cotton. There's some differences in fiber here. I'll say the Pima cotton is a premium fiber. It's longer, it's thinner, it's stronger. And so, however, it doesn't grow well in the non-arid regions of the U.S. Cotton Belt. You bring it to South Alabama or Central Alabama, you bring it to Louisiana or Georgia, the yield for Pima or the Egyptian varieties might be here, and the other varieties would be here. So the other varieties do extremely well in the arid places such as Arizona and California. But you see the different species and where they originated. Upland cotton is what we refer to primarily Gossypium hirsutum, and I suspect when you're buying fiber, that's what you're buying if you're buying yarn or whatever, I suspect. But again, those really account for most of what's done in terms of production in the U.S. and probably around the world. Again, Pima fits the arid climates. It looks beautiful as a crop here in our part of the world. It just doesn't produce. And every now and then, things have a way of cycling. Things have a way of circling back around. Oh, this would be a great idea. Because Pima probably, the current cotton market is probably 68 cents a pound. To make profits, probably it needs to be around 80 cents. So it's a terrible time in the U.S. cotton industry. Pima would probably say, and I don't have a current price, but it's probably $1.70, $1.80, maybe even $2 a pound. Pima commands a lot more value because of, again, the properties we talked about. Okay, Gossypium hirsutum is where it's at. Anybody know what hirsutum means? There you go. Thank you. I've been in some circles and I would point to some bald heads, but I won't do that today. Okay. Okay. So this is what upland cotton looks like on the day the bloom opens. It's white, it's creamy, it's beautiful. Egyptian cotton doesn't look like that. It's yellow. It's a beautiful, beautiful flower. But these flowers are very temporary. But I want to talk more about that in a minute. But just showing you the difference in the two species that we grow. Again, from Texas east, it's all Gossypium hirsutum. There might be a few pockets in West Texas where they try to grow Pima. And Pima, to maintain the quality properties of it, you actually have to gin it a little bit different way. It's called a roller gin versus a saw gin, which is what's done, again, throughout the U.S. Okay, a little bit of history. We can talk about it, but my wife and I lived 32 years in South Georgia. And Georgia was founded as a penal colony. What does that mean? It's where they sent the bad folks, and they kind of populated Georgia that way. The first reported plantings of cotton in the U.S. probably date back to the 1600s, around Jamestown or something like that. But in Georgia, the first reported planting is at the Trustees' Garden in Savannah. Now, what are trustees? It's the prisoner that, he's not going to run off. He's not going to do something bad. You can kind of trust him with the keys. But a number of years ago, I don't know, maybe it's been 12 or 15 years ago, I had a young colleague get married, and he got married in Savannah. And the reception was at the Trustees' Garden, and we got to see that place where the cotton was planted. So, all right, the third point here is a big one. This is seed cotton, and by that I mean this was probably hand-picked, so it's cleaner than it would come from a mechanical picker. But if you touch it, it's got the seed in it. And of course, it has to be ginned and the seed removed, and this is pure lint over here, to be processed into fiber. I do remember in going to Mississippi when I was a little boy with my mother, and she and my aunt that lived in Scuba took me out to a cotton patch and let me pick. And I had a pillowcase, and I filled that up with this stuff. It took a while. But prior to the invention of the cotton gin or cotton engine, and there's a lot of debate about who did it and that sort of thing, but cotton was sort of a novelty garden crop, because you would sit around at night and you'd be separating the lint from the seed, and it takes forever. I raised the point a few minutes ago. Everybody shelled peas before? How about shelled butter beans? Butter beans are a lot harder to shell than peas, but doing this was even more tedious. So you might work, I don't know, a couple of hours and get a pound or so of fiber. Well, that doesn't fuel an industrial machine around the world. But when the cotton gin came into manufacturing, it changed the world, and cotton really became a truly industrial crop. And it's really been entwined with Southern economy and Southern life and politics since then. This is I guess, I don't know if this was the original Eli Whitney example of a hand gin, but it was hand run. But rather than getting a pound or two for an evening, you might get 50 pounds a day from this little machine. The concept is not much different today. It's these saws, and you've got the seed coming in to engage a bunch of saws, and it might be the gin stand. You'll see it, maybe it's about 7 feet wide or so, and I can't remember how wide the saws are, but you create a seed roll, and what's happening is the saws and the action of the saws are snatching the fibers from the surface of the seed. So it's somewhat of a harsh process. It's controlled by speed and heat and all that, but it changed the world in terms of cotton as taking it from a garden commodity to something that was for industrial manufacturing. And I say here that the earliest textile mills were in England and in New England. And all this seemed to coincide with what we label as the Industrial Revolution. All right. This is a quote I lifted from a national corporation. Anybody ever heard of Berkshire Hathaway? You laugh. Well, what name do you associate with Berkshire Hathaway? Thank you, Warren Buffett. Well, apparently, I don't know when it was exactly, maybe in the 50s or 60s, his company or his stock resources, they purchased a big place in Berkshire Hathaway. Well, guess what? The U.S. textile industry was in decline. I think he thought he was buying a bargain. Well, what he bought was a dud. But what do now? They do a lot of other stuff. And so that umbrella name expanded tremendously, and they do a lot of other stuff. They bought cotton textile mills at a bad time, but they turned it into gold in some respects. But so this is a point that's a generation ago, most of the U.S. cotton was spun in U.S. textile mills. In fact, if you went down the road, probably 50 miles from here, Sylacauga, Alabama. My wife and I said we lived in South Georgia. There was an Avondale Mills plant that had been there over 100 years. They closed the doors. And today, rather than most of the U.S. cotton spun or processed in domestic textile mills, it's gone. And that number is probably, I put here 20%, that number may be 10%. In other words, the U.S. textile mills have disappeared. Can they come back? I don't know. Obviously, they disappeared because of cheaper labor elsewhere, but most of our cotton is processed around the world and then comes back to us. You've got a lot of players, and you can read on your shirt, or your garment where it came from. And so again, the U.S. textile industry has dried up significantly, but we still continue to grow cotton. Okay, big picture wise, maybe 1800s, there's probably some more accurate number that I'm going to say, but maybe 70–80% of our population was rural, and had some activity and farm related. Today, we think the number is less than 2% of the people. Maybe 1.5% of the people are involved in producing whatever food and fiber we grow. But in the old days, cotton was the driver. Cotton was the cash crop that really drove the economy. And I've heard these figures, and I tend to believe these figures that Alabama grew 4 million acres of cotton and 4 million acres of corn. I've seen a number that said 5 million. I don't believe it, but I will tell you today that in 2025 we may plant less than 1.3 million acres of row crops altogether in the state of Alabama. So now let me ask you, why did they grow 4 million acres of corn? Feed the mules and whatever was drivers they were going to use to produce the crop. And so again, cotton was king in a way, and it was really the backbone of the economy. And again, the town we lived in South Georgia, big ag economy. We have a bad year in peanuts and vegetables and cotton. The car dealership, he knows he's not going to sell many trucks. Or you see the ripples. I'm going to say it a little later. Cotton is a very management-intensive crop. It's been that way. It still is that way today. The economic multiplier, if a cotton farmer spends, I'll say 1,000, it may be a little bit less than that. Let's say he spends $1,000 to grow his crop, an acre of crop. It's probably a little less than that. But that number is going to reverberate through the economy, the local economy, and produce about $6,000 or $7,000 as he pays labor, as he buys vehicles, as he buys supplies, fertilizer, you name it. So it's an economic driver. There's some commodities, pine trees are probably one, that there's not that much give and take. You put them in the ground and you wait 20 years or 15 years, but so cotton was a real driver there. And again, it is so involved in the life and the livelihood and the economics of the South in such a big way for so long. Okay, moving to the second, another part. This is the boll weevil. Remember, cotton was native to Central America, to Mexico, that part of Central America. Well, this boll weevil is sitting on top of a young cotton fruiting structure that we call a square. The scientific name is this, Anthominus grandis. But again, the boll weevil is native to central Mexico, where cotton was originally found, but it feeds on the reproductive parts of cotton. The flower buds, we call them squares. Now, they're squares. There's 3 leafy structures that surround that flower bud. There are 3 of them. There's nothing square about them, but we call them squares for some reason, okay? And then once the flower opens, and I've shown you a flower, it forms a seed pod that we call a boll. That's what we're growing the crop, not to grow stalk, not to grow leaves. We're trying to grow seed pods, which contain seed, which also the fiber emanate from the surface of the seed. And you can see how massive a buildup can occur from boll weevils. I don't know if this number is inflated, but even if it's 4 or 5 times, that's a lot of damage. Now, so Central America was where the boll weevil was. It started moving north as cotton was ingrained across the South. It was found in Brownsville, Texas in 1892 and moved across Texas, moved across the southern cotton belt. It was found in Mobile, Alabama in 1909. All right, backing up here, this is the reproductive structures of the immature reproductive structures of cotton. This is what we call, this is the smallest structure we can recognize and call it a pinhead square. Now, you're familiar with a straight pin, and it's got the nail looking part on, and we call we size it that way, pinhead square. Then a kitchen match, that's what this one's gonna be. And from this size square to an open bloom is about 3 weeks. The day before that cotton bloom opens, it's gonna produce what we call a candle. And so you see that candle sort of bulge up, and you know, hey, that flower is going to open probably the next day, and that's what happens. But the boll weevil can damage any of these structures, and there are a bunch of other pests that attack cotton as well. But the boll weevil was key in so many ways. So the day that, now this is upland cotton, we're not talking all about Pima, but the day that flower opens, it's white. It self-pollinates predominantly, if not exclusively, probably in the first few hours after it opens. Now, we can get cross-pollination if bees are active, but primarily it is self-fertilized. The next day that white flower begins to turn pinkish, and it continues. And then after several days, it sort of dries up on top of that seed pod. It'll usually fall off, but it doesn't always fall off. So that's sort of the progression you see from the flower that appears, again, 3 weeks after that tiny structure appears. And so the plant produces fruit from the bottom up. This particular node, and then next node, and then it can also have limbs, and it produces them out, those limbs, depending on how dense the plant population is. So some time frames. From planting the crop till we see that earliest square is probably going to be anywhere from 50 to 65 days. Usually that's temperature driven. The warmer the temperature is, now that assumes that we have reasonable moisture, but the warmer that temperature is, the faster things will move along. And then from that smallest square to an open bloom is about 3 weeks. And then once that flower opens, like you see right here, till this white bowl fluffs out, is about 50 or 60 days. In the cool of the fall, it can decline and take longer. So again, that's very much temperature driven. Now, a cotton plant may bloom 6, 7, 8 weeks. It really probably, if it was well watered, well managed, it probably could make an optimum meal with as little as 4 weeks of bloom. But we probably, in our part of the world, we may harvest cotton from, say, 6 weeks of bloom. Okay, anybody ever seen this woman? You have, okay. And she is located where? Enterprise, Alabama, which is on the southern border of Alabama. This is a Grecian woman, about 14 feet tall, and she is holding up our friend, the what? Boll weevil. And she's offering tribute to the boll weevil. Why would she do something like that? You don't know? Okay, we're going to learn. Okay, this is a quote from the Smithsonian magazine from an article dating back to 2017. The boll weevil was devastating to cotton. And this talks about the migration of African Americans from the South as a result. I really think this is colorless. When economic devastation hits, it hits everybody. And this is an example I found. The Enterprise Gin, which is, again, in Coffee County, Alabama, sort of central Alabama, but right on the Florida border. Lo and behold, this was their crop in 2014 and reduced 67% 1 year, and then the next year 90% reduction. If that drives your economy, it's devastating. Well, what it drove them to, and why this woman is holding up the statue, it compelled them to look at another crop, and that crop was peanuts. And people saw the boll weevil coming across the South, and they knew, it's going to hurt us. It's coming. Well, there was encouragement to plant other crops, and George Washington Carver at Tuskegee Institute had demonstrated the great value of peanuts, but they weren't takers. Because, hey, you grew cotton, I'm paying you to grow cotton, or I'm loaning you money to grow cotton, or you're farming on my land, you're growing cotton. Well, it was devastating. Well, one guy, and his name may have been Sessions, but I'm not 100% sure, but he convinced a banker and a farmer, say, here's the money, you grow peanuts this year. He had a good crop, everybody else experienced what you see here. And so it showed them, hey, we got a viable option. And so, again, with the devastation of boll weevil, they welcome peanuts, and peanuts have been a mainstay in the South, at least the coastal plain of the South ever since then. I wanted to say something else important about that. And I told you I was a faculty member at the University of Georgia for 21 years. In the early 1980s, Georgia at one time planted 5 million acres of cotton. In the 1980s, they were down about 110,000 acres. The head dogs at UGA said, y'all don't do any more research on cotton because it's dead. Okay, again, another statement from an entomologist at NC State. Again, this is the boll weevil on the cotton square. But I see my time is getting a little short here. I'm talking, giving too many details. Scientists, USDA did some research and said, we believe we can eradicate the boll weevil. Well, there are so many pests that attack so many of our crops that feed on multiple crops, that's impossible. Well, boll weevil is unique in that it's got to have cotton to live and to reproduce. And it's the sole source for the boll weevil. Well, so they said, hey, the science is there. There was a tremendous amount of debate over this, but I really do believe the boll weevil advanced the discipline of entomology, that is bug science, if you want to say that, probably more than anything. But it required including every acre, compelling every acre, which is hard to compel farmers about anything. But you had to spray every acre going into the fall with insecticide. And then this is a boll weevil trap, and this was developed, and I don't have it with me, but there would be a little orange sliver of, looked like about that big. It was a piece of plastic. It was impregnated with a sex hormone, not hormone, but pheromone, which attracted this color, attracted the boll weevil, and the pheromone helped too, so it could help monitor them. So long story short, farmers joined, federal dollars shared some of the cost. The boll weevil has been eradicated from the U.S. It began in the Virginia, Carolina areas in 1978, made it to Alabama in 1987, was completed in 1995. The last boll weevil in Alabama was probably seen, I can't remember if it was 2000 or 2003 in Mobile. There's still some right at the border of Texas and Mexico, so there's a lot of activity there. But the eradication of boll weevil was a tremendous boon to Southern farmers. It probably saved cotton. Again, I talked about, I was in Georgia. When I went to Georgia, they were planting 300,000 acres of cotton. After the eradication of the boll weevil and the introduction of certain technology related to insect management, Georgia planted 1.5 million acres of cotton. Just because it fitted, and it was a great fit with peanuts. And so again, and I probably should spend a lot of time here, but one of the other great developments was genetically modified crops, which conferred insect-related control as well as herbicide-related control. The insect part of that has been fabulously successful, reducing the use of insecticides. Probably, this number is probably low, probably by close to 90%. So it's been a great boon to farmers. And so, again, I see I'm running short on time. I'll just make this point. In general, cotton has been, remains a very management-intensive crop. It's always been that way. A lot of pests, a lot of trips over the field, specialized equipment, specialized harvest equipment, post-harvest equipment, and so forth. This is a one-row cotton picker, probably a 1950s version, harvesting one of 2 experiments at Auburn. 2 of the oldest cotton experiments in the world are at Auburn. This is the colors rotation, which deals with a nutrient deficiency, potassium, That's why it was instituted. But the other shot, I probably should have included it, was about the old rotation. It was instituted in 1896, so it's over 125 years old. But there's cotton been grown on that site for over 125 years now. And even the cotton that's received the purpose of the experiment was to demonstrate the value of winter cover crops as well as crop rotation. And even where there's been zero nitrogen fertilizer used, but we've used winter cover crops such as crimson clover or hairy vetch, we've been able to make yields. When they started out, they were probably making 300 pounds an acre. Some of those plots, just with crimson clover as a winter cover, we're making 1,500 pounds. And that's, again, 125 years. So, again, great success there. As you see in the textile industry, in any industry, technology displaces labor. It happens. And that's this is the point. I probably got this slide out of whack here. A book that was written in the year 2000 was The Second Great Emancipation. And the cotton picker, mechanical cotton picker, which came to use in the late 1950s. Let me say, I was given or loaned one of these machines like this for use. And I can tell you, the man who got it first, I bet he thought he was the king of the world. Because picking cotton's hard work. It's hard. But I think he thought he was king. Now, when I drove this machine or a machine like it, it was like riding on top of a cement block. It was hard. It was hard. But it did great work. But this book sort of documents that when the cotton picker came, it freed up labor, and it resulted in further migration. And I think it was black and white. It changed how things were done. In fact, in some of the southern states, in some of the areas, when cotton picking time came around, they would let out school so everybody could go to the field and pick it. All right. Again, technology displaces labor. This machine is the latest, is an example of the latest and greatest. Incredible. It may pick 80 to 100 acres a day. And the newest version of this may cost $1 million. So it's a real challenge there. That wrap cost about $35 per wrap. And so that probably contains, we can probably gin from this about 4.2, 4.5 bales, something like that. All right, again, I'm gonna have to speed up. Talk about Cotton Incorporated now. This is the 1970 shots. Anybody wore suits did you wear a suit like that? Okay, synthetic fibers. In 1960, cotton's market share in the textiles, apparel market was dropping like a rock. And so farmers banded together and said, hey, we need help. And so they formed Cotton Incorporated. And its sole goal was to increase the demand, the profitability of cotton. It supported textile research and activities, and even probably assistance to textile mills on how they did their processes. And again, it also supported ag research. There are offices around the country. If you ever want to see a tour, the world headquarters at Cary, North Carolina, they would welcome a tour. I have no doubt. I've listed a bunch of things that they've done, and this probably doesn't do it justice. And for time's sake, I won't mention some of their contributions. Some of these are textile processes. Some of these are agricultural processes. On and on. What they've done, they've sought to sustain cotton as a viable competitor in the fiber market. What's the competitor? Man-made fibers. When we're growing cotton, it's biology. We're not making nuts and bolts. When you make man-made fibers, everything is the same. When you're growing cotton, it's not quite like that. So, all right. Talked about the cotton pickers. That's one incredible machine. There's all kind of efficiencies. I'll just make a quick point. This shot was taking about this was an experiment I was involved in, harvested 6 of these rolls, and we harvested one more just ahead of Hurricane Michael. Okay, and we took these immediately to the barn. We didn't weigh them. We weighed them after the storm came through. But prior, these 6 or 7, we harvested anywhere from the equivalent of 1,400 to 1,700 pounds of lint per acre. After the storm, 400 pounds an acre. Just showing the risk and the devastation of the storm and the type of risk that farmers face every year when they grow the crop. All right, just a few quick comments. Everybody, you've seen the giant loaf of bread that we call a module, okay? That's depicted here on the left, and that really contains, if we gin that contains anywhere from 12 to 17 bales of cotton, versus the round bales are going to give us about 4.2, something like that. Yes, ma'am.
Can you show us height, those dimensions?
Okay, a module would be about, it wouldn't be quite as tall as the ceiling, but it would be about from me to that wall, and it would be about this wide. Okay, so it's a lot of cotton, and and so it requires a lot of man labor to do this. When you're doing this, you've displaced about 5 people and tractors and so forth. So this is such an efficient way to process the crop. All right, this is I'm going to go very quickly through what happens at a gin, but this is the raw cotton, the seed cotton from a loaf of bread type module being fed into the gin. You can drop the plastic, the round roll on this same deal, but you've got to deal with the plastic because it's terrible. One of the most vile things is to get that plastic in the cotton fiber. That's the no-no. Big contamination issue. So this is where it really happens. There's a lot to get in the cotton of this process, but this is the gin where these things are here, and the seed go one way, the seed fall out, and they're going to a warehouse in the back, and then the cotton, the lint, the fiber is blown back up into the system and goes through process of cleaning and maybe coning in preparation for making a bale. And so this is a gin, and there are actually 3 gin stands, and they're probably rated at 20 bales per hour. So the 3 of them together, they can probably do at least 50 bales an hour. And so again, these gins in the gin season, they're running 7 days a week, 24/7. And so then the cotton, the fiber, the seed are going to disappear, and the lint are going to go through some cleaning processes, then wind up here over the press. You saw the earlier slide with the mules going around packing the cotton. Well, this is a universal gin press, and I can't remember if it cost $500,000 or what, but it's a very expensive part. But it's compressing all that fiber into a very tight bale, and it's a bale of cotton. USDA standard is 480 pounds. In the ginning process, it's a little. There are certain boundaries, and the average average bale weight in Alabama over the last 4 or 5 years is like 490 pounds. So, but if you get too high, it's in the trade, and then you're penalized for it. So, but again, so he's packaging, he's wrapping the bale. This gentleman is grabbing a sample, which is going to be used for fiber analysis. Again, and it's going to be wrapped, and it's going to be sent to a warehouse, either on site or somewhere else, awaiting textile mill purchase or some other person. So I'll hurriedly go through this part to give a standard understanding of what each crop was. The USDA classing system was established in the 1920s, so that cotton grown in Eufaula, Alabama, was the same as in College Station, Texas, if it was the same quality. In other words, they could stand. There's a great commitment to standardization, and this is the fiber analysis and the assignment of that quality is accepted around the world. And so the the 10 regional offices, and one of them used to be one in Birmingham, but there's no longer. In fact, all the Alabama cotton is either goes to 2/3 goes to Macon, Georgia, the rest goes to Memphis, Tennessee, which is the U.S. headquarters of the classification system. But they generally handle in excess of 20 million bales a year. Okay, the samples collected at the gin, then it goes to the classing office. The classer is sitting at a station, and he or she probably handles 3 samples every minute. And they subject it to HVI, which is just the term, high volume instrumentation. And the instrument gives most of the readings, but then the human eye also studies that for other junk. But all the other properties are measured by the machine. So color is extremely important. I know I saw the brochure on colored cotton. Obviously, in the broad market, the most valued trait, well, I'm going to talk about what do you think the most studied trait is of cotton in terms of quality? Staple length. Okay, I think that's a good guess. I'll come back to that. Color is assigned, and I'll again hurriedly go. This is the color chart. As you go this way on the chart, it's more yellow. As you go this way, it's brighter. And the base grade is right here. And over the past several years, we've kind of evolved to a premium grade of a 31.3. So we really want to be here, but we don't incur any penalties if we're here. We may get some premiums if we're right there. Okay, so other qualities that are studied: staple, which refers to length; micronair, which is determined by forcing air over a known quantity of sample, and it reflects sometimes whether or not the fiber is mature. Or sometimes I think about it, and I don't know that I'm right. Some people would argue with me, but I think it sort of reflects the density of the fiber. And then we have strength and length, uniformity, and so on. Let me go back to staple. And remarkably, people used to do this by hand. And I was talking with one of the guys at Memphis last year. I was doing a podcast, and I said, "Can you do it by hand?" He says, "Yes." Which again, when you're talking 30 seconds of an inch, that's pretty amazing. So a staple would be a standard, for example, would be 30 seconds would be sort of the standard grade. But we're shooting for a premium of 36 of a staple of 36, which would be 1.125. So the classing office is going to give you a number of staple, or it's going to give you actual inches. And again, the inches is probably more accurate. Now, it's also not the measure of every fiber. It's the upper half mean length. So if you had 100 fibers here, you're only looking at the 50% of the longest fibers, because we're talking biology, not manufacturing nuts and bolts. And so this number, length uniformity, sort of indirectly reflects how many short fibers we got in there. But let me come back. Micronair, again, is the density of that fiber, and there's a preferred range. And if we have drought years, we get high mic, which adversely affects what? Anybody know? Dyeing is affected. Dyeing is, making it blue or green or whatever. So micronair really reflects maturity of the fiber and also its dyeing property. Strength affects the efficiency of spinning, and the longer, stronger is preferred. And I probably would have agreed with the statement about staple. And length uniformity, again, has been used against us in some ways. And so our normal numbers on upland cotton, I'm showing some of those. And then we got measures of leaf grade, and see, that's got some trash in it. And so that's reflected in the grade numbers. All right. So maybe it's telling me my time's up. Seriously, I've quit. Oh, okay. Again, the human classer takes that sample, and the sample's bigger than what I'm showing, but he or she looks at it and says, do we have other stuff in there that's not supposed to be? And there are certain penalties for this, and there are certain years where we've had serious penalties for example, seed coat fragments. One year, the Macon Classing Office, because of Hurricane Sally, I think, sat on us for 2 weeks. And so when it went into the gin, the seed just went everywhere. And so they had 40% of their crop went high seed coat fragments. And the spinning industry doesn't like junk so again, all these other things, and plastic is a big, big no-no. All right, why they matter? The end uses determine, the preferences of what the textile mill wants. And I don't know if I believe this number, but I've been in some textile mills, and guess what? How much they told me the cotton cost of their overall cost. I heard a number of 66%. That's hard to believe that the raw product that they're purchasing I figured it was labor or machinery, but they said anyway, so they're different kind of, and y'all know more than I do about they're all kind of different. There's at least 3 or 4 different types of spinning technologies. And what your end garment is determines how much quality you need and so forth. One thing that happens in a textile mill is they're trying to put down 60 or 80 bales at the time. And they skim them with something like a lawnmower, a little bit at a time from each bale. Cotton Incorporated gives them a computer program that tells them which bales to put in that laydown and where to put them, so that they can have, when they're going through the yarn process, they've got as consistent a product as they can. Great advancement there. So, all right, I think the most scrutinized fiber property is. Nice. Okay, I think I'll stop there. Any questions for me? I've got 6:01. Supper's probably out there. Oh, great question. Seed are a very valuable. They're high protein source, and they're because they're on the expensive side. They probably are used mostly in the dairy industry. However, there's a compound that's cholesterol-like called gossypol, and so you have to limit how much can be in a diet to something like 20-25%. If you're excessive on that number, you can cause some sterility in bulls. But so it's a premium feed. It gives a lot of energy, but it's primarily milk cows. Yes, ma'am.
You have brown cotton in your email as your email.
That's my name. So Cotton Brown is my email. That's what I learned in working for a company, is to brand myself. So rather than SMB 0165, I'm Cotton Brown.
Okay, now I don't know what my question is appropriate, and I will ask the question anyway, and that is, you haven't said anything about brown cotton.
Yeah, and part of it is again, the commercial industry, they want bright and white. I bought when I was in Australia, and I have a garment still that was natural brown cotton, and I wear it still. If it can be done, it's obviously a specialty and niche market, but it needs to be probably because you can get a little outcrossing, though cotton is primarily self-pollinated. You probably need to be a little isolated from normal producers to grow brown cotton. Okay. And I've seen brown, I've seen green. Actually, this has a little red fiber in it. So anyway. Is this the brown cotton lady? Okay.
Thank you. That was so informative. I also would like to just invite you down the marketplace, because we do have a full display of what we're doing with our brown cotton. And my question is, which of the cover crops do you recommend the most? And we cover crop. We don't use any anything chemical at all. So cover crops are very important to us.
If you can grow crimson clover, I don't know your environment, but crimson clover.
South Louisiana.
Okay, so you can grow crimson clover there. It would give you some nitrogen and relieve. In some of our trials where we've been doing it for years and years, it totally relieves the need for nitrogen fertilizer.
Mm-hmm.
So crimson clover would be one. Hairy vetch is another option. It's a little more aggressive plant that's probably harder to deal with. And if you get in a just right environment, your crimson clover may mature and produce seed before you plant. And so you may can plant, it may come up next year where you don't have to plant it. Now that makes for careful management, but that would be an option. The small grains are easy, and they're good. Rye is a really good. Wheat is okay. The other small grains work too, but the benefit of crimson clover is that nitrogen component.
Excellent. Let's see, I was gonna ask you one more question, but I think everyone's hungry for dinner.
Sure.
So please meet us in Marcos. We'd love to show you what we're doing.
Thank you.
And then so if I understand correctly, that's the I'm moving. Sorry. There you go. So do I understand correctly that the micrometer piece that we talked about has to do with measuring the extent to which cotton will take down?
It reflects that. Okay, the process is whatever little part of sample is exposed to airflow and the resistance that the fiber produces is that number. If we have in the South, if we have extreme drought, we have high micronair, which reduces the acceptance of or makes the acceptance of the dye a little more erratic and inconsistent. In Texas, West Texas, which grows huge amounts of our cotton, they sometimes have low micronair because their season terminating too quickly, and it suggests they got immature fibers, which are not going to. They're probably going to be less strong and probably a little more difficult to spin.
Is there any so
Yeah, I don't know that there are genetic differences in varieties on micronair. And from a farmer standpoint, what he wants to do on micronair is simply avoid that penalty range. I don't see that as a real target for the breeders in that regard. And maybe somebody else could better, a Cotton Incorporated person could give a better answer than me on that.
So you can, it's like work. Yeah, you can do it.
I think we have one more here.
Sure.
It's almost like you're there.
What do you see as the long-term future for cotton production in the U.S.?
We're in a terrible place. The 1980s were a terrible time for U.S. cotton production or crop production. We are at a very serious place this year and last year. There were people that made good yields but no profit. One thing that may help us is we've had such a wet spring. In fact, I was on a conference call and podcast earlier this week in Alabama. There are places that have only planted less than 20% of their crop, and the deadline for planting is today. And so they've been prevented from planting because of wet weather and cool weather. So that may reduce acres across the U.S., which would give us some relief. COVID knocked demand in the head. We thought we'd come back. I'll give you one example if I can indulge. And there's a cotton marketing co-op that's based in Prattville, Alabama. And this guy wrote an article 2 or 3 years ago, and he was quoting the demand. The demand is supply and demand. Demand for cotton's down. He cited the global beer index, and it's thought beer was immune to inflation. It might vary a little bit. But in the world, it was down like 1.7%. But in the US, the beer index or whatever you want to call it was down 8%, which suggested if the man's not buying his beer, he's certainly not going to be buying more jeans. And so that sort of reflects, so demand is a big issue. We've got competitors. Brazil's a big competitor. So it's a very challenging time in the US cotton industry. And I would say probably across crops in the South, it's tough. Just because of where commodity prices are and where input costs are. So yeah, I think we're very challenged. But in some places, if we're gonna grow crops, I don't know what else we're gonna grow, but as I said, we've lost crop acres in a lot of places and will this year, I think. So thank you.